Welcome to Engaging Students with SAM Labs. We're going to be talking about building confidence for you as an educator to implement STEAM and coding with your kindergarten through 8th grade students. So our hand-on approach at SAM Labs models with flow-based coding, and it progresses to block-based programming so students can solve problems in a real-world context using our wireless physical and virtual blocks. We have a web-based SAM Studio platform where you can code in both flow-based and block-based coding. So we're going to walk through that. I will show you some of our content hub, which is full of resources for teachers, like standards-aligned lesson plans. So grab your free token here in just a second, and we're going to explore the solutions that SAM Lab offers for STEAM and coding. So this is just a glimpse at the session, what we're going to be doing in the next few minutes. So we will take a look at who SAM Labs is, so what that really means. We'll take a look at the coding progressions. We'll take a look at the actual platform where you can get in and do some coding, and then I'll do a brief demo, and then we'll code together before we take a minute to explore the curriculum. So let's chat a little bit about SAM Labs and who SAM Labs is. So our vision is to inspire and empower generations of problem solvers. And to be able to do that, we have to have our mission, which is to equip and empower educators with the tools, the know-how, and the mindset to reach learners' potential for computational thinking. And we are able to accomplish that vision and mission through what we do, which is teaching STEAM and coding, developing students' computational thinking skills. So we refer to this approach as computational teaching. We've developed a classroom approach to computational thinking that has lesson plans. So those are those instructional resources in addition to many other instructional resources. We have our software, which is no install on your end, available to access over internet or Wi-Fi through the web, and our hardware, which is our SAM Labs kits, our blocks. So let's talk a little bit about the coding progression that we offer. So we start in our coding space called SAM Space. Both of these are housed in the same platform, so you don't have to switch between or toggle between two different websites. They're both housed within SAM Studio. So SAM Space is our visual coding platform. It's flow-based, so drag and drop, and there are dots to connect the different virtual blocks to help build a foundation for coding, but the focus in our STEAM content is on next-gen science standards. Students build out prototypes, which is an excellent point of entry for students who have never coded before, or students who are learning the language. And it also serves students with special needs, as well as teachers that don't have a technical background. Then we move into, so this is designed, again, you can see the grade levels up here. So kindergarten through 8th grade are what we have content offerings for. Our STEAM content is designed for kindergarten through 5th grade to participate in. Our SAM Blockly content is aligned to Learn to Code, and it is designed for 4th through 8th graders. This content is heavily aligned to CSTA standards, so those computer science heavy concepts with some other layered in. And I forgot to mention that our SAM Space and our STEAM content is next gen science standards aligned, but it's also heavily aligned to CSTA and other content areas. And both of these are designed to get students to level up in complexity from kindergarten through 8th grade, so progressing in their computational thinking abilities. And the block-based, again, is focused on coding itself. So that level of complexity is gearing them up to be prepared to move into script-based coding in 9th through 12th grade. So these are some of the features of SAM Studio. A couple of things I want to point out. Like I mentioned, both of those coding platforms are in one place. So you got SAM Space, which is designed to go with the STEAM content and flow-based coding, and then SAM Blockly, which is block-based coding which might look a little familiar, and that's designed to go with our Learn to Code content. Our platform is web-based, like I mentioned. There's no need for IT to come in and download anything, and there's a shortcut that students can use to be able to access their projects without internet, so they can still get in there and tinker with their content. And then our virtual blocks help have a non-reliance on hardware, so students can use the virtual blocks within the space and still have all the capabilities that a student with hardware would have. And we currently integrate with Google Classroom. We're working to integrate with lots more for back to school this year, lots more LMS in addition to Microsoft 365. So I'm going to take a minute here to kind of talk about our subscription service. So we have moved to a subscription model for accessing SAM Studio, and you'll need a trial token to get in there and tinker around with me here in a minute. So if you'd like to pause the video, feel free to do that. I'm going to leave this link in the session links, so feel free to check out the video tutorial on how to get your token all logged in and everything. You can click the link included on the session page. So I'm going to, again, put the link that you can activate your token there, or you can go to SAM Studio, so studio.samlabs.com, and drop this token in. So that's trial, and that's -AETC -T2Z CC So again, if you want to pause the video here, get yourself activated before we get into the demo and the code along. So once you register, you'll have a continual space to access SAM Studio. So it's for teachers and students. This also gives you access to our content hub, which includes our lesson packs and activities. You can save projects to Google Drive or your local browser. And you can share projects between students and teachers. It makes it easier to do that. Once you have activated your token, this is what SAM Studio should look like for you. So again, we're at studio.samlabs.com, and I just want to give you a quick little tour of the space before we get started into our demo and then our code along. So within SAM Studio, you have both of those coding platforms I mentioned housed in the same place. So SAM Space, which is our flow-based coding platform, and then SAM Blockly, which is our block-based. And you can, again, access those by just hitting this little addition mark here. And this is how your students would add the shortcut to their device, or for you to add to your device. So you can click that button there. You might notice the little triangle in the top right corner of all of my projects. That is to show that all of my projects are backing up to my drive, which you can see here, my little image there. Showing that I've connected to my drive. So that, again, that's an option for you to pop in there and connect. So with me, I have my handy dandy Steam Alpha Kit. So within my Steam Alpha Kit, I have my DC motors, I've got my light sensor and my RGB LED, and then a few different things to build using my blocks. So just wanted to show you my actual hardware. So let me dig into a project real quick. All right. So I'm going to show you, just for a little demo purpose, I'm going to show you some SAM Space information. So I have already grabbed these blocks, but because I want to show you, I'm going to take them off my space. There. So down here across the bottom of my screen, you can see I've got my output virtual blocks, my input virtual blocks, my output virtual blocks, and then I've also got behavior blocks. So, and I've got an RGB LED. I have got my slider with me, and I have my light sensor with me. So playing around with those options, I'm going to grab the light sensor input block. So as you can see, I just dragged and dropped it there. And then I'm going to grab my RGB LED. All right, so right now you can tell they're not communicating with each other, but to get them to communicate, I'm going to connect the dots here. And then you can see a nice little flow happening between the two, to show that to indicate that they are communicating as a system. So when I manipulate my virtual light sensor, my RGB, let me change that color so you can see it better. Oh. All right, so I can manipulate my light sensor to sense more light, and my RGB LED is going to get brighter. Now, let's say I want to make this actually like a real system that you might encounter. So I'm going to grab an inverse switch and throw it in the middle of these two. As you can see, the dots connect and the system is all blue to indicate that it's the same system communicating together. And now when my light sensor senses more light, my RGB is going to show less light. So this might be something like a smart system light, or thinking about your cell phone. When you walk out into the sunshine, it's going to be brighter than when you walk into a dark room. So right now my blocks are virtual, and what I'm going to do is connect my light sensor blocks. I just turned it on. And then I'm going to connect via Bluetooth. So I'm going to go to pair device, pair, and then my light sensor's color is going to change to indicate once I've paired, which is a helpful little classroom management tip or feature. So now you can see my light sensor, the on color has indicated that it is connected all the way. So now my light sensor, it has a gray cube on the bottom, and then it's actually showing me numbers to display how much light it's detecting. So as my real life physical hardware is detecting light, my virtual RGB LED is reacting based off of that. So I've got it down to 0. My RGB is very bright. And then I'm in a bright room, so it senses a lot of light. My RGB is barely putting off any light. Now what I'm going to do is connect my physical RGB LED to show you that you can do both. You can connect virtually, or you can use the physical hardware as well. Pair device, RGB LED. I think I clicked the wrong one a second ago. So again, my light is red, and then in a second when I connect it, it's changed to this purpley blue color. All right, so it's going to be a little bit of a challenge to see, but as I manipulate my RGB, my light sensor, my physical RGB is going to get brighter based off that. And then I could just disconnect this one and just have my my RGB block set up to react physically. So I'm going to turn off my light sensor block. And now when I manipulate my virtual light sensor, my physical RGB is reacting based off that data, that input. So now that you've had a little peek at SAM space, let me show you the space designed to go along with our Learn to Code content. So again, SAM space is designed for those beginner entry-level students for those computational thinking concepts while integrating STEAM. And our Learn to Code is designed for those 4th through 8th grade students who have, again, there's a beginner spot for them, but a little more computer science heavy. So in this space, you might recognize this block language. So the blocks click together. You grab the blocks from over on the left-hand side, and you'll have different blocks appear for whatever actual hardware blocks you're using within the space. So you have all of these options. And to connect to devices, I'm going to click right up here where it says devices. Okay, so within my space, I built this code to involve a slider, which is this button, and an RGB LED. And right now they are virtual blocks, so I'm not connected to my hardware. My hardware is off, and I've got these virtual blocks here. But I can still run my code, which I just wrote a code to, when my slider value changes, so when I manipulate my slider value, my RGB is going to run through random light colors. So I click run, And then I can come over here and manipulate my virtual slider. And you can see my virtual RGB is reacting based off of that. Okay, and click stop. If I wanted to, I could easily add a device. So I can go right there. And that's how I added my devices to begin with. So you'll just have another virtual block appear, which you can easily remove from project. Oh, uh-oh, it might not let me now that I've, nope. Hang on a second. Let's get that out of here. There we go. Okay. So, and it will let you delete them if you have them written into your code, which we just saw. So once you add those blocks, add devices, the device blocks that correlate are going to appear here in this SAM Labs blue. And you can choose different actions, values, and events for each of those blocks. So let's see what it looks like when we connect. So I'm going to turn on my slider. Again, it's just a really easy little push button here. And then I'm going to connect. And now my slider, my virtual slider is going to disappear, but I'll still have this box to indicate that my actual physical slider has been connected. So I'm going to leave my RGB virtual. When I click run, so I'm going to change my physical slider, and my RGB virtually is going to react based off of that input. So it gives you some options for versatility in using the blocks, distributing the blocks as an educator across your context. All right. And within this space, we connect to all of these different blocks that we have with SAM Labs, anything from a proximity sensor to a pressure sensor, servo motor, DC motor, and tilt sensor. We also integrate microbits into our Learn to Code content. And then we also have a partnership with Vernier, and we work to integrate with Google Sheets, and then Parrot Drones and Sphero Spark. So you have all of those options to integrate within SAM Blockly. And you can go right here, or you can go right here when you're looking for your devices. All right, so now we are going to work to code together and build a flashing light alarm. So you're going to need to be in SAM space. Feel free to pause the video as you're building to kind of challenge yourself, or feel free to go step by step with me as we walk through this build. So I'm going to place it here, and then I'll actually build it after we go through the directions. So your first step is to drag the light sensor block onto the space and your LED, your RGB LED onto the canvas. Then you're going to connect the two. So you're going to grab this, connect it over here to this dot. And then test what happens when you manipulate the actual light sensor. So play around with grabbing this and moving it across to indicate the light sensor sensing more and less light. All right, so now that you've had a second to do that, let's get into actually building the flashing light alarm. So change the color of the RGB LED to red. If you don't know how to do that, no big deal. You just come over, click the block, and then you'll have a setting cog that appears underneath. Click that, and then you can choose the color. And again, I'll show you in real life in just a second. You're going to drag the compare block, which is one of the behaviors, and you're going to drop it on the line between the light sensor block and the RGB LED. Set your compare block to greater than or equal to 10. Again, click the block, and then you'll have a little gear that pops up that you can manipulate the value. And then you're going to test your system. All right, so I'm going to pause it here for a second so I can switch gears and show you the actual build within SAM Studio. Okay, now that we have tested and built out this first section of the alarm, let's keep going. So our next step is we're going to add an interval block. So grab that interval block from the behavior blocks within SAM space, and you're going to place it between the compare and the RGB LED. Now test your system out. And if we were in real life, I would ask you to get with a partner and share your findings of your testing. Okay, awesome job building with me. Thank you for your patience and working through. I hope that it has been successful for you so far. So what we're going to do now is build a flashing siren, and we're going to do that within Sam Blockly. So if you will access Sam Blockly, so remember you can do that. You can just go back and click right here and then click Sam Blockly. So you're going to access Sam Blockly within that space, and then we will code together. So when button is pressed, and we're going to look for the repeat forever and do. So we're looking for a loop here. But under the button actions menu, so again, you're going to go into the space and find that actions menu. And then we're going to find when block is pressed. And we're going to drag that onto the canvas. And then under the loops menu, we're going to find repeat forever do. And then we're going to put that block under when the button is pressed block. So we're going to need to add a button device. So we did that. We're going to leave it disconnected, but this is what you do to manipulate the button virtually. And then this is where you can find when button is pressed, like we have here. And then we're going to go to loops and repeat forever do. Okay. Now let's keep going on with our build. So you can see right here our final image of what we're going to be building, but let's keep digging through. So under RGB LED, we're going to want to add one of those. So go to add device, RGB, and then that list of blocks will appear, or that section of blocks will appear for us. We're going to want to grab set. So we've got that one, and then we're going to go back under our buzzer, our actions there, set buzzer 2. Then we're going to have our set buzzer pitch here under general. Wait. Yep. We're going to grab our set buzzer pitch too as well. So let's grab that. Uh-oh. It's not filling up for me. That's all right. We'll keep going. And then we're going to duplicate the code. So once to do that, you just right click, and then you'll have these options to delete blocks, collapse blocks, add comment, or duplicate. So again, that is our little code along. I hope that you were successful in your code. And if not, I hope that you were able to debug and figure out how to make your code successful. When you signed up, you got a trial for Sam Studio, but I wanted to let you know about the options you have in Sam Studio Lite. So you can still tinker around in all of that, because I know it's summertime and your token might expire before you get the chance to really dig through and explore the options within Sam Space. So I wanted to give you some lessons that you can access and fully teach and tinker around with without having the full pro access. So first grade, we have a few different lessons. Third, fourth, within this is the STEAM content. So you'll have a copy of this slideshow you can click to go visit. Check out those options there. All of our lessons have a lesson plan. They have slides that go along with the lesson, a student handout that's already integrated into Google Classroom if you work with Google, and students step-by-step to help not only students but also teachers walk through those things, which I'm going to show you a little more in detail here in a second. So in our Learn to Code, here are the lessons you can tinker around with that are available fully within Sam Studio Lite. So again, if your trial token expires before you get the chance to really explore, don't worry, you can check out those lessons to work through. All right, so let's take a minute to actually check out the curriculum. So we're going to scoot over to samlabs.com and follow through the course tab. And I will show you some different content things and some resources available to you, but I wanted you to see or to have this within your slides to be able to refer to. So within the curriculum, we have lots of different options. So we've got our STEAM content, like I've mentioned a few times. It's designed for kindergarten through 5th grade. Again, heavily aligned to those next-gen science standards with computational thinking and CS concepts layered in, as well as some Common Core ELA and math to help implement STEAM in your classroom. And then we've got our Learn to Code content, which is designed, like I mentioned, for 4th through 8th graders, heavily aligned to those computer science concepts, standards, and they are also, students are able to work through a cyclical process with building out their systems, testing and debugging before having opportunity for differentiation within their lessons. Our Maker content kind of goes along with our STEAM and Learn to Code, but it's more open-ended, exploratory with students, so they have an opportunity to kind of apply the skills and the concepts that they learn within Learn to Code and STEAM and build out their own projects and ideas. We also have distance learning options, asynchronous Nearpod lessons to help engage students if you're in a virtual or blended setting. We also have our Creator Series, which is really low-tech lesson plans that provide STEAM and coding, whether your students are in the classroom or at home. And then we have our partnership with Vernier that are heavily aligned computer science lessons that integrate their more sensitive blocks and sensors. So let's take a second to check out the resources within STEAM. So you'll be able to see our standards alignment for all of our grade levels within this one-stop shop. We have starter lessons for kindergarten and 1st grade and for 2nd through 5th. These lessons are designed to be exactly that. So they're a good starting place to get familiar with the lesson plan structure, get familiar with what SAM space is, get familiar with what inputs and outputs are, and then actually working through at least one build together. And then this one is for the upper grades, so you can see coding and working prototypes, and then working through those behaviors, which is those blocks that impact the input and output. So let's dig into a 4th grade lesson plan pack. 4th grade just happens to be my favorite, so I tend to gravitate towards it. We've got a lessons overview, which is exactly that. It just at a glance gives you the next gen science standards and what the blurb or the little summary of each lesson is at a glance. So as you're planning, you can check that out. There's also a standards alignment map and then medium term planning. This is one of my favorite documents. It kind of at a glance, while I'm planning for the year or for a semester or a term or even a week, I can at a glance tell exactly what my learning objectives are for each of my lessons. I can tell a picture of the prototype my students are building, the final system and what it should look like within SAM space. And then I can also see any materials I might need, keywords to look out for, and then my standards alignment within there. So let's look at an actual lesson plan pack. So within the pack, you'll have these 4 resources that you can easily download. So when you click download all, it's going to automatically save those into a folder in your drive for you. And as I mentioned, it's aligned or integrated with Google Classroom. So these are in a Google Doc or a Google Slide, so you can easily edit them how you need to. So our lessons are a modular structure. There's going to be warm up or a learn, do, reflect structure. So easily able to break apart and fit your time needs or your time constraints. So our students begin with a warm up and a mini lesson, and then start off with a build as a class before getting into a challenge. That first challenge is going to have a bug built into it for our 2nd through 5th grade students. So encouraging that computational thinking strategy of working through that bug and encouraging perseverance for students. Then there is an opportunity to continue testing out on this concept that they've started learning before getting into chili challenges and an exit ticket. So this is an opportunity for you as a teacher to differentiate. The warm-up and activities are scripted, and there will be keywords are bolded to help bring those out as you're teaching. There's also opportunities to link forward. And as a teacher, we wanted to give you enough that you feel confident, whether you have a background in STEAM and CS or not. You can take this and kind of run with it. We've also got suggested references built in and our keyword definitions throughout. And then when you get into the actual building or the actual programming, there's a step-by-step for teachers with troubleshooting tips as you're walking through to help your students without necessarily giving them the answer, because that's always a hard line to balance, is how can I facilitate their discussions without giving them the answers. And so I feel like this with troubleshooting tips is a really helpful tool for that. So that's the first challenge and the second challenge with the bug built in. And again, as a teacher, you'll know ahead of time what the bug is, and you'll have the directions on specifically how to debug it. So that's a no sweat situation for you. There's checking for understanding before getting into the chili challenges, which are an opportunity for you to differentiate for your students who maybe need a little more practice within the basics of the concept taught, or challenging or pushing your students further before they get into reflecting. Like I mentioned, there are slides that go along with these lesson plans. So a great visual to help assist in your students' learning. Interactive features, checking for understanding questions layered in. This is Blocky, our little character within STEAM. And your chili challenges are also going to be there. The student handout, we'll take a look at a space for your students to draw out their designs, to get familiar with those keywords, annotate their systems, and record results. And then we have this awesome resource for you and for students called the Student Step-by-Step. So it does exactly that. It's got the instructions right next to the workspace or the build to help them as they're digging through these challenges, and to help you give them a little facilitation and do that confidently. So those are the lesson plan packs within STEAM. You'll have the same resources within Learn to Code. They just look a little bit different. So again, you have the starter lessons giving you and your students a starting place to get familiar with Blockly, getting into what the blocks do, working with microbits, what is computational thinking for students, and then you can get into the actual lesson plan. So let's go into 6th grade. So we've got our lessons overview, which again is going to give us a little summary of what each lesson plan entails and the blocks needed to do so. We've got our standards alignment map, which can be a little bit small when trying to share screen, but you can see aligned with CSTA. And then we've got the medium-term planning document. So again, at a glance, I can tell as the teacher what the final system should look like, the learning objectives, keywords, and then what CSTA standard I'm teaching. And the lesson plan packs, again, you have these 4 resources. So the lesson plan, again, a modular structure. You'll still have all of those resources built in. So you have the troubleshooting within the build, block by block, step by step for students. Student slides to share. You've got Sammy, our character with Learn to Code. And again, it's that modular structure, so you can really break it apart as needed, checking for understanding with questions answered right after that. And again, this is within Google Slides, so you can manipulate as needed. And the student handout. Again, great space for students to document their learning as they're working through these challenges. I love the traffic lights to kind of self-evaluate, giving them a little more autonomy in their learning and ownership. And then we've got the step-by-step, which is going to do just that as they're walking through these more complicated builds. It really helps them figure out where they are in the build and where they need to go. I did briefly touch on the digital classroom, but if you're interested, please check it out. There are asynchronous, ready-to-use lessons with Nearpod integrations, literacy connections, and these digital classrooms are designed to be teacher-facing. You can find it by going to samlabs.com, and then you go to the courses tab, which is where our content hub is. You'll be able to see the digital classroom there. Thank you so much for taking the time to code along with me today. I hope that you learned something, and I hope that you're encouraged to bring STEAM and coding into your classroom with SAM Labs. Would love to chat with you further. If you have any questions for me, please feel free. Connect with me on Twitter. I'm wearing WizKid on Twitter. And my email with SAM Labs is at ashley@samlabs.com. As a fellow Alabama educator, I am pumped to be able to chat with you about SAM Labs and STEAM and coding. Thanks for joining. Oh, and be sure to visit our booth, whether you're in person or virtual. We have a virtual booth, but also feel free to reach out to me. Thanks.